Good afternoon, or good evening, wherever you are. My pleasure. I'm Dave Thomas, and it's my pleasure to be here with Erik Meijer, who's just given a wonderful keynote on Actors in the Cloud, as well as some great inspiration about careers for new grasshoppers. So, good to see you, Erik.
Yeah, Dave, that's a long time ago that we did a gig together like this.
It's good.
Yeah.
So, I think the exciting news for those of you might recognize his clothes, but this is actually the outfit for Erik in his next life. He's now done his own startup called Applied Duality, and this is really exciting. And you want to say a bit about the sorts of things you're doing in Applied Duality?
Yeah, definitely. So as Dave says, I'm trying the startup thing. And Applied Duality, as the name says, I'm trying to apply all the techniques that I developed in my career so far, which all have to do with duality, to solve developers' problems. And in particular, what I'm focusing on is real-time streaming big data. So that's kind of the reactive framework, and trying to make that into an enterprise-grade product.
So maybe you could just update us. I don't think a lot of people realize that the reactive framework has moved out of Microsoft thanks to the Microsoft open source efforts and contributions from people like Netflix and so on. What's kind of the state of the reactive framework in terms of the open source world?
Yeah, so we open sourced RX in December last year, so December 2012, so last year's of course relative. About that same time, the Netflix folks started to implement their version for Java, and that project is incredible. If you look at the amount of pull requests and contributions that go into the Netflix version. The .NET version, what people often don't realize is that code has been under development since 2007, so it's incredibly mature code. It has shipped on the Windows Phone. If you have a Windows Phone, it's in there. And the code has also been rewritten to be super optimized. So that code base that you see for the .NET version is kind of stable. I don't expect that we're going to do a lot of kind of additional development in there, but the reason that we made it open source is to make sure that other implementations, like in the Java one for Netflix or the JavaScript one, remain compatible. Because the whole value that you get from RX is that if you have a client and server that both have deal with asynchronous event streams, that the operations are semantically compatible. And so if your server is written in Java, your client is in JavaScript, you want to have event streams, you want to be able to partition the processing of your event streams across the boundaries. And so that's the kind of main goal, is to make sure that all the implementations in different languages are following the same protocol, the same semantics. And so that's on the semantic side. What we also want, and I learned quite a lot about that when we did the JavaScript version, is that you want the API itself to feel native to the language. So for example, in JavaScript, there's already map and filter on array. Right. So instead of coming up with new names like select and select many and where, you want to reuse the same names. And in Java, since Java doesn't have extension methods, there, the way the API is structured is quite different, because now you cannot do it interface based, so you have to make different design choices that feel good for Java, but the underlying semantics is maintained.
Now, does this apply to the wire format as well?
That's a very good question. So I'm hoping to avoid kind of going too low level to the wire format, and the reason is that I look at RX really as an interface, and then there's an underlying implementation. And if you push the wire format if you standardize the wire format, in some sense you're not defining an interface, you're defining a concrete implementation. And let me give you an example. I've been working on a binding for Logly, which is a logging format. They have their own API, they have their own format of how to kind of send your events as JSON objects with a certain shape. If you push the wire format too far down, then it becomes hard to kind of glue these things together. So and maybe I'm naive, but I do think that it's better to kind of not go to that level where and then say you impose the RX interface. It's more on the behavior level, and whatever transport or whatever wire format you want, you pick.
Yeah, I can't imagine someone reading massive amounts of syslog records with RX wants to have them all transformed to some other format
Yes,
on
exactly.
the way, because
Yes.
the cost of doing that
Yes.
for the benefit is...
Yeah, and you see this often with other protocols where they have to define a common type system and so on, where really in some sense you're just sending bytes over the wire, and then on the other end you interpret that. Yeah, I mean, even if you say you have Java on the server side and JavaScript on the client side, for me it doesn't make sense to try to define a common type system between Java and JavaScript, and I think for those situations where performance is not super critical, JSON is kind of I think has won, so it's a default.
Okay. Just switching to some other things in your talk, there were some, as usual, only slightly controversial remarks. Talked about the issues, I think, which many people have talked about from NoSQL, of basically the fact that SQL sort of in a positive way firewalls a developer from the database engine, but in a negative way prevents you from doing a lot of things as a programmer, and gives you a kind of strange kind of API. It's part API, but it's also part programming language, so it's just a different animal. I think one of the things you talked about was the fact that it would be nice if the features that are in, there are a lot of great algorithms implementations inside the database. So if SQL Server or DB2 basically said, here's our great B trees and our storage management that does this, our logging system, our transaction mechanism, and let me program with those, essentially treat them as libraries or actors, then you'd have a much more sort of composable system where users could work with data in the way they saw it. So is that correct in terms of what I heard?
Exactly correct. So if you look at the database, I mean, these are kind of incredibly fascinating machines, right? And there's like a lot of decades of tuning and optimizations in there. But as you say, the weird thing is that the way it's exposed to the programmer is via this weird SQL language API. Concretely, when you do link to SQL or entity framework, you start with C# with expression trees, which is like a high-level representation of your query, an algebraic tree. Now, in order to get it into the database, you first have to translate this tree, which is very similar to the tree that will be in the database at some point. You have to translate that into SQL, into strings, send it over the wire. There it will be parsed. The optimizer will turn it into some algebraic tree, and then it will execute it. So it's like incredible distance between what you really want to do and what the database exposes. And the same holds for the storage engine, the log manager, etc. So I wish that if you would have a database that would be broken up in components where you can pick and choose, and that would be fantastic. SQLite has a little bit of that, where it exposes like a little VM that's very interesting, like a bytecode VM. But I think that's kind of one of the things that I find very fascinating is, can we break this database into the components where you use what you need. And one interesting thing is Windows has a kind of log-based, like an areas log system in there, system.io.log. So these things do exist, and if you look at Google's LevelDB, it's kind of similar to that. So I do believe that the NoSQL movement is pushing more towards, giving the database in terms of reusable components that you can pick and choose.
So Rich Hickey, of course, gave a great talk yesterday in Datomic. I think he did it before you arrived, but you, of course, know Rich.
Yep.
Did a talk here in the summer at GOTO night, and Datomic has kind of an approach like this. Have you, looked at it in terms of? I mean, the B trees are real implementation trees. You can program in, the real programs, and happen to use data log as kind of the language, but you can really work with entities and deal with them, and it supports immutability as well. So
yes,
I think something along the direction.
That's definitely along the direction. I think what Rich is doing is extremely fascinating. One thing that I would like to pick out there is that he chose data log, which is another interesting choice, because that has been used in the database world, as far as I can see, typically as a more theoretical thing. So, but there's very few databases that expose data log as their query language.
All the good data log guys got hired to build SQL engines, I think. That's a story I heard, but maybe that's just the data log people say that.
So I think it's very fascinating that he's using data log. If you look at Joe Hellerstein in Berkeley is also kind of leveraging data log. And I think one of the things what Datalog gives you is that it allows you to define recursive queries in a more natural way. And I think that's something that's very important. If you look at a lot of the data structures that we have, like social data and so on, are naturally recursive. Right. So I think the expressive power of Datalog is very important. And that's something that, if you look at Link, is also lacking, because it's more based on SQL. So I think what Rich is doing is very interesting in many respects, but maybe from a developer point of view, it's also the fact that data log suddenly becomes real instead of something that you read about in some database paper.
Well, I think it's really part of in a closure program. It's really part of it's really marrying the computation on the data. It executes in your process, as opposed to in the database, off the database process. But certainly the transactor decomposition and things like that is very much, I think, the sort of thing that you're talking about.
And so also to kind of again tie back to SQLite. If you look at the SQLite bytecodes, it's also very fascinating. They have little instructions for doing transactions, building indexes, doing joins, and I always wondered why the relational database is not exposed as a VM, because underneath they are there's a machine there that executes programs which are SQL programs, and that always they're doing the same thing. If you look at the database, they're doing the same thing, but they use different words. So instead of abstract syntax trees, they call it query plans. And I wish that if they would open it up, then we could have more innovation from the language and the VM world, moving into the database world, and vice versa, because these guys know a lot about optimizations and so on.
Excuse me. So one of the classic things. Since I'm old, I can look like a DBA. One of the classic challenges is if you have a large, corporation, and you want to share data across that, is that if you let everyone, build their own indexes and their own B trees and so on, how in this new world will they share this data? I mean, because many people who work with data do not have they're not computer scientists. They don't, expect to work with maybe B trees or things like that. So, what are they going to get some special affordances, or do they just say, look, you dummies, you just have to know how to program this way, or I'll make up the schema yourself because we're just storing all the data. I mean, how do you deal with the fact that a real data semantics? You can get false joins very easily if you just keep people a whole lot of data, and if you would say, well, look, they all have customer numbers, so I'll just join these. I mean, this data model is crap. We don't need any of that stuff anymore.
Yeah, that's interesting. So I do believe that the illusion of control that you have when you have a DBA that controls the schemas and the data and the indexes and so on is an illusion. Because what happens is that probably most people bypass the DBA and put their stuff in a spreadsheet, and they send across spreadsheets. So my feeling is that a lot of people are using Excel as a database, and if your data is not too big, that works wonderfully. But there's no schema in Excel, and we have now seen a couple of kind of examples where the extreme dynamic nature of Excel leads to problems. But I do think that, and even if you have a DBA, then a lot of companies have many different ways to define the same kind of entity, because different departments, or if you have mergers of
Sure.
companies. So I'm not sure that having like the data models and so on defined by a single group will solve any problems. And if you make it more accessible to developers, I'm not saying that the end users should do that, but if developers can make that easier, then I think the integration becomes easier, so it is less brittle. But I don't know. It's like, I think it's yeah. I don't think that this thing solves the real problem. It just hides it a little bit more, and then people will work around it anyway. And my favorite example is, imagine that on your normal file system, you would have to have a schema before you can save a file. That doesn't work, and it slows things down quite a lot. And often, you don't need the whole schema, right? You only need to know what is the key, and the rest of the columns don't really matter.
So maybe it's this notion of a schema on read.
Yes.
Or the fact
Yes.
that I have some descriptions, or many descriptions, which can be useful, and maybe you'll compose those descriptions again. So it's not so much a single schema, the single control point, but the fact that you'll need metadata or descriptions,
yes.
and you can use those along with the fact that, by the way, there's an index on this, and index is this, but it's not all of this one. So
Yes.
so people will have to do, it won't be RDF, but there'll be some sort of hopefully computational description for these things as well as the things themselves.
Yes, although what I find fascinating is if you look at a lot of the web APIs, say Twitter, where they expose their data as via REST API, there's no formal description of the metadata. You go to a website
Right.
where they have like English examples, it's like, oh, this is kind of, in the result you get, it might have these things, and in practice, it works surprisingly well.
Good examples.
Yes.
Are still the best, one of the best ways to communicate.
Yes, and I think by leaving it a little bit vague, you gain flexibility, that you can consume that data from different languages. So I'm very scared about like an Uber type system that and so I rather kind of err on the side of okay, just let's keep it informal and pick something like JSON, which is really property bags, and then you interpret it when you read.
Right. So just to switch channels.
Yeah.
You mentioned in your talk the current hot debate in the JavaScript community about futures.
Yep.
And you proposed actually what looks like quite a nice solution. Do you want to just maybe if we give a pointer at the talks, the slides will be online,
Yep.
and Nathan Mars's talk and the other ones from YAL that you referenced are also online as
Yep.
videos for people who are looking in talks in Australia. But what do you think about this? I think you said use comonads for the solution.
Yes, that's kind of a little bit of a joke. People that kind of it's interesting for me. I was a very fanatical kind of functional programmer in the late 80s, and then since then I've become super pragmatic, and so for me a monad is very much like a design pattern, and it's great that there's like a formal categorical basis behind it, but you should look at it more as one of the tools in your toolbox. And the same with co-monads. It's like an API pattern or design pattern. Now, the interesting thing, I think what is important about the debate that is now in the JavaScript community is that we need a way to make asynchronous programming easier.
Right.
Because everything, once you go outside your machine boundaries or even to disk, you have to deal with asynchrony. You cannot make blocking calls. So that is great. Now, the thing is like, how do you expose this to the programmer? And what I was arguing for is the co-monadic approach is where the continuation of the future takes the future itself as an argument. But the continuation is called once that the future, the promise has been kind of resolved or terminated, and then inside the continuation, it's okay to kind of get at the value. And so now that finished task represents the outcome of the computation, whereas in many other approaches, you're passing multiple continuations, you have to compose multiple continuations, which I think is not the right thing. Now, if you look at Rx, that is also based on multiple continuations, but the interesting thing is that is the result of the computation. So you should never have continuations kind of passed into a function, but you have to return something that has the continuation, and then you compose on that level. So it's all about like how do you compose these things, and I think the current approach that a lot of people have, the monadic approach, is not the easiest way to kind of do the composition. But we'll see. And the other thing is that also you really, if you look at .NET, where in C# and VB they have async support, you don't even ever use these operations because that's all hidden by the compiler. So the compiler does all the kind of plumbing for you.
Right.
So I do believe that JavaScript and other languages definitely also need something like that, because otherwise you're doing continuation passing by hand,
which is quite ugly and error prone.
Error prone, and that's what the compiler should do. It's like you're doing work as a human that the compiler should do.
I suspect we'll have a Node revote.
And to be honest, I think Node has, to kind of just rant on that, I think Node has many good aspects. I think it conceptually pointed out that everything should be asynchronous all the way down, but I don't like to program it with callbacks. And I think, because your whole program gets turned inside out. And I know companies where as interview questions you have to write like a loop using callbacks. And so their point made, right? That's kind of the compiler should do that.
When I was young, they'd tell you could you write this program just using interrupts.
Yeah. Yes. Yes.
It can be done, but in many cases, it's just a lot easier to do some simpler form. The other thing is that asynchronous. It's quite awkward to do. A good practice is use a state machine.
Yes.
And that's not a natural. It's not a very natural model to do that in the kind of node-like programming world. Right?
Exactly.
So particularly if it's complicated. Right?
Yeah. But again, I'm very much an optimist. So I just see the fact that people are thinking about it is progress.
Oh no, I think it's great. I think.
But we're just scratching the surface.
I think people are realizing as they build larger things that they need more support for those sorts of things.
Yeah.
Back to another subject you mentioned, which I'm glad I wasn't the only person who read. I read the preview, then I read the thesis on REST. Then I went back and we did a bunch of REST APIs, and then asked ourselves, are they really RESTful? Do we pass the test? I mean, how do there are some great books coming out, and I think we're getting a much better idea for doing this, but I've just been feeling guilty because I always just want an API, and I think that's actually pretty natural for most developers. And you had a comment on that, and I think you also referenced some work at Google where they say on a project where they found that approach too. Yeah.
So first of all, let's kind of talk a little bit about REST. So what I find strange is that people cannot define what REST means in a formal way where you can, you know, like I know what functional programming is, you know, that's programming with mathematical functions, and I know what mathematical functions are, so that's great. And then you can say, well, so Haskell is real functional programming, or as I call it, fundamentalist functional programming. And then you can say, well, in other languages where, you know, we allow side effects and strictness and whatever, but you still know that it's kind of, you know, where it comes from and how it differs. Right. But with REST, it's like, you know, it becomes more like a religious kind of debate. And also the fact that, you know, by accident, I don't know, probably by accident, you know, HTTP has these verbs, so are these really kind of, you know, everything you need and so on? So that's kind of, you know, my desire for precision, which is not kind of there. And then what is a resource? You know, they have these kind of vague words that I don't know what they mean. And why is it bad to have an RPC style thing? So for me, all these things don't really matter, because what you say, as a programmer, I just want to program against an API. And the fact that this service is exposed as REST or SOAP, or I couldn't care less, because that's the implementation. It's like the wire format. And in some sense, I do believe that having an API is more abstract, because now you can switch out the implementation. So REST is way too concrete for me, because it is a certain encoding, a certain implementation of an API. So for me, the API, just give me the API, and then the implementer of the API can swap out whatever. I wouldn't care. And I don't think anybody types in the REST URLs, because the first thing a developer does is to write an API that takes objects, sends them to there, and gets objects back. So they turn it into RPC, which is apparently bad, but I don't know. So maybe I'm completely naive, but I know this is what I see everybody do. And all the client libraries for a lot of these web services are like that. And I don't know, that's this, I think the easiest way to deal with this as a developer.
Yeah, I mean, I thought if it's so important, why can't I just say, you know, like put an annotation on this procedure call and say, make it HTTP, or,
yes.
Right? Which I can understand this is supposed to be, but I mean, in which case there'd be a standard way to do this, and you'd say, okay, I understand this has to go in this format because that's how the web does it, but you know, I really shouldn't have to worry about marshalling, unmarshalling, and converting all this. You know, that should be somewhere separate, as opposed to concatenating all these strings, which I personally find quite error-prone and tedious.
Yes,
right?
yes, and maybe here again, I mean, I look at this thing and I see a lot of syntax, right? So what is the difference between writing blah 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 /A/B or blah 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 question mark, you know, A and B? Yeah, I don't see any difference. It's just different syntax. But apparently there's like a deep semantic difference that escapes me.
We'll have to ask Steve Benoski later.
Yes, yes.
He's here. So one other point. I think, you know, you've been, you know, coming back to fundamentalist functional programming. It's quite exciting now. We have new conferences like Lambda Jam coming up, and functional programming from Scala, F#, Clojure, and other languages starting to be used more. You know, you seem to be now moving from the initial school where, you know, well, if you don't know monads and comonads, and you know, you shouldn't come into the room, right?
Yeah,
so you failed the test. You know, that's next. You know, I mean, in objects we always had reflective, so if you didn't know the reflective tower, if you didn't know what a metaclass was, how could you possibly do object-oriented programming? Then we found out if you didn't know what a metaclass was, you could make a big mess, right? Like change object or something like that.
Yes, yeah.
So it seems to say that, you know, a lot of these things are inspired or can be viewed through, you know, category lenses, and that may be an interesting choice of words, but maybe that's a bit overemphasized, because I think it's one of the things that makes people who don't have that particular kind of mathematical backgrounds. I mean, I'm an engineer. I've got a strong math background in, you know, signal processing, you know, numerical mathematics and so on. But I certainly, you know, most engineers don't take categories. I certainly didn't. So maybe that's kind of overemphasized, or or maybe that the Haskell community needs to learn how to speak in other ways when in other audiences, or how do you think about this?
Yeah. So the way I look at it, if you mentioned engineering, which I think is an excellent example. If you're an engineer, say a mechanical engineer, you build models using math, but the models are very much abstracted from reality. You make all kind of assumptions, like there's no friction and there's a point mass and this and that, and you do that as a conceptual framework, and it's a conceptual model, and you know that this is not really the real world, but you kind of make these assumptions, and then you kind of want to learn more about what you're going to do. But then when you build the real system, there's all kind of other constraints that you have to deal with, and engineers realize that the model that they made is not the same as the system that they then produce.
Right. They're always partial models.
Exactly. And I think the same is true when you use like monads and category theory. Category theory is more like your differential equations, but your code is always kind of different, and you have to realize that. And I think that's one of the things that I do believe that you have to keep in mind very carefully, that you write your code that's kind of where there's a conceptual model, and they don't hardly ever map one to one. The other thing is that people, I don't know, it's like I don't know what it is where they kind of like, maybe it's this mystique because it's hard to understand. I don't know. So I'm really trying to take away all the kind of mysticism out of the monads and so on, because in the end it's just a way to model things that you want to write in code. The same for functional programming in general. You can say, well, you write what I call fundamentalist programs. I do believe that the Haskell community has done one really good thing, and I think Simon Peyton-Jones is the one to kind of praise for that, is they always kept the language pure.
Absolutely.
And then you can experiment again, then you can write these models, and you cannot cheat. So you have to be pure. And then, once you've learned that, then you apply it in practice. And what I really liked is that a lot of the more pragmatic languages like Scala, F#, Clojure and so on, they are not taking the real purist view, but they say, well, what we have to do is we have to write programs, you have to interact with the imperative world and so on. So they're using the insights from the pure model to build real things. And I think it's a matter of also maturity, I think, where you can let go of the kind of the real strict kind of adhere strict to the monadic stuff. No, you know that, okay, and then I kind of apply these concepts to my actual work. And for me, the essence of functional programming is really that you make things first class, that you can make computations first class, that you can abstract patterns that are repeated. So you can say, so really what a function is, it's like a set of statements that you turn into an object itself. And we talked about this in the past, but there's really not that much difference between objects and functions. Right. And in many cases it's a syntactic difference, and even if you look at the implementation.
Sure, no. I mean, people get horrified when you say, here's the simple, what's the difference between object-oriented programming and functional programming? Well, in one you get the environment and have to find the function, and the other you get the function and have to find the environment.
Yes,
right?
exactly.
Well, that can be it, right?
Yes.
But if you see the meta-circular interpreter,
yes.
it's the read eval, there's very little difference in the actual.
Yes, exactly. And so I think it's always good to emphasize what is the same instead of kind of focus on what's different, which is something that computer scientists like to do, is they always kind of try to pick things down and view at the differences. I don't think that's very productive. And so just look at this thing holistically and say, what can I learn and what can I steal, what can I apply?
Well, thank you very much. It's been great to have you. Very enjoyable. You'll be able to catch Erik's slides online and his videos as well. So,
thank you,
Dave.
Erik. Okay.